Okay, now we have a glass of iced tea sliding on a horizontal surface. It starts off at 1.22 meters per second, and our job is to find the stopping distance for this. Now we have a coefficient of friction of 0.15 that gives us an indication that friction will be the force stopping it. I realize I don't have a mass given for this, so probably I don't need to have a mass. So I'm going to put M right there. Now, as always, I do want to get my force normal right away. So force normal along a horizontal surface would just be equal to force of gravity. So I'll just write M times 9.8 here as my force normal. Okay, after I determine that, I again go to my conservation of energy and I ask my questions again. I will place the origin along the bottom here, or the horizontal surface. I always want it to be the lowest place as possible. So I ask, is this thing moving initially? And yes, it is. So I will give it several boxes of kinetic energy. And then I say in my next question, am I above the origin? Well, no, I'm actually on the horizontal surface, so I'm not up at all. So no gravitational potential energy. And I say, are there any springs attached? And I look and I go, nope, I don't see any springs, so no elastic potential energy. And then work done. Well, I'm looking, is there an actual applied force on this to make it go somewhere? And I look, I see 1.22 meters per second, and I go, no, that's a velocity vector. So that is not a force vector. So this glass of tea is sliding all by itself. There's nothing pushing, pulling, or tugging on it. Therefore, there is no work done. So I complete and give one more box to kinetic energy, because I realize all of the energy present in the beginning case is kinetic energy. On the right side, I go, well, we're coming to a complete stop. So in the second case, this glass of iced tea is not moving. So I go, well, I guess there's no kinetic energy. Did this thing go up or down at all in the vertical direction above the origin? I go, no, so therefore no gravitational potential energy. Any springs attached anywhere? No, I still don't see springs attached. So no elastic potential energy. Well, then I go, well, it slid to a stop. I do see a coefficient of friction here. Therefore, there's got to be some thermal energy. And that's all the energy left I have, so I'm going to give it 4 boxes. So what this means is all of the energy of motion in its initial case is getting converted to friction, and this thing will slow to a stop. Therefore, the conservation energy equation is kinetic energy is equal to thermal energy. Now let me plug in what I know. I say then, 1/2 m, because I don't know the mass, multiplied by 1.22 squared is going to equal my thermal energy, which is force normal times mu times distance I go. So then I go m times 9.8, that's my force normal. I look and find my coefficient of friction of 0.15, and then multiply by a distance d, and in this case I don't know d. Well, then I look and I go, well, I know I can cross off my m's. I don't need to have those because they cross off on both sides. And one more time, for stopping distance, I guess I don't need mass. Then I just need to find my displacement d. So my distance then is 0.51 meters. And that's how you find stopping distance.